Hello, today I'll be doing in the first year 12 spec, alright? So it is gonna be on complex numbers. Uh, Complex numbers. I'm gonna name of one. Probably gonna do multiple videos because it's really hard. Okay, because it's year 12. Alright, let's start with the first question. And it says if z equals cos theta plus I sine theta, we have to prove that 1 plus z over 1 minus z equals 1 I cot theta over 2. Okay, so we first list some identities that we need to use. So first is cos theta equals 1 minus 2 sine squared theta over 2. And it also equals to 2 cos squared theta over 2 minus 1. And sine theta just equals to the normal double angle, so it's just cos theta over 2 or sine theta over 2, yeah. Because these two formulas came from the actual these two formulas came from the half angle formulas, but we rearrange it to find what cos theta is, as the answer have theta over 2 in it, and this is the best way to actually get those. And we have to write this in terms of z, which is given here. So do that. So 1 plus z, 1 minus z equals, so that just equals to 1 plus cos theta plus I sine theta over 1 minus cos theta plus minus I sine theta. And our goal here is to cancel out the ones because, well, we can always use cos and sine to get cotangent, and we can also cancel them out. But 1 is weird because when you take it out, you can actually, like, it's hard to take it out. Yeah, because nothing times 1. Okay, yeah, whatever. It's hard to take it out. So you're gonna use -1 in the top to cancel out the 1 here, which is right here. So we make cos theta into that thing. So it's 1 plus cos theta, but we make 1 minus 2 sine, wait, no, wrong one. 2 cos squared theta over 2 minus 1. We're just gonna keep the sine first, and that'll be 1 minus. Now we need a not a -1, we need a +1 now. So we use the top one. We use this one. We use this one. So then the minus become a plus because it's inside brackets. It should be inside brackets. So 2 sine squared theta over 2 plus I sine theta. No, minus. Okay, so now the ones cancel out. We only left with these two. We can't do any further, and we can't do anything further, so we have to sub this in for the sine. So that makes it, so it's 2 cos squared theta over 2 plus I, or 2 cos theta over 2 sine theta over 2. We don't need the brackets since they're all multiplying, and that's 2 sine squared theta over 2 minus I 2 cos theta over 2 sine theta over 2, and the 2's we can take everything, the common factors out. So 2 cos theta over 2 bracket cos theta over 2 plus, well, that's just I sine theta over 2 all over to sine theta over 2, and that becomes sine theta over 2 minus I cos theta over 2, and the 2's cancel out, so then that just becomes cotangent. It's just cos over sine. But so we get half the answer ready, theta over 2. Now we have to make this into just an I. So that's weird because the i's at the bottom. So what we can do is, because we know that negative I squared is 1, we can do something to make that like that. So what do we need? So if we do negative on this one, and then we can take out the negative. This is squared, this become I, will become the top. So that would be the easiest one right now, because if you put I here, it become negative. Actually, that will work as well, I think. Let's just try that. So we do negative I squared cos theta over 2 plus I sine theta over 2. We'll leave the bottom the same. Over 2 minus I cos theta over 2. That becomes cot theta over 2. And we can take out the I, the negative I. That becomes, actually, we just have to take out I. That becomes sine theta over 2, as the sine's at the front here. That'd be minus I cos theta over 2. And we've done the thing, we've done it. So then you see the bottom and the top have a common factor, or like you can just cancel them out. Cancel these two out. That becomes I cotangent theta over 2. That's it for the part A of this question. And so for part B of this question, they say that on the organ diagram, the points O, A, Z, P, and Q represents the complex numbers 0, 1, Z, 1 plus Z, and Z, and 1 minus Z respectively. Show these points on the diagram. That's stupid. I don't like that. Organ diagram. Oh my god. So the 0 and 1's easy, so the O must be here. We'll do 1, A is here, and here it says Z. So because Z, I'm assuming Z is from part A of the question, which is right here. This is Z. Actually, no, it isn't. Z is cos theta. Z is cos theta plus I sine theta. What does that mean? That means this is a part of a unit circle. So that means that Z must be in the unit circle. Wait, let me think about this. Yes, it does mean it's a point on the unit circle here. So we're gonna, oh my god. Okay, so Z can be like anywhere here. Let's do Z. Z is here, and it says 1 plus Z. So Z plus 1. So 1 plus Z just means that you draw another unit circle around 1. And Z is still here. And then it is, and then we have to do 1 minus Z. So 1 minus Z. 1 is a real part of a complex number. So if you subtract that from the Z, that just means Z must be over here somewhere. Let's ignore the first thing, the first unit circle first, because that's not quite important, as this is more important. So because that is a certain distance, this much distance, and if you minus 1 from it, as it's a unit circle, it will go right to the other side of the unit circle. So no, that is not Z, that is should be called P and Q. So P and Q. Okay, we're gonna draw back Z. You know what? Z is here. Actually, Z can't be there. Z is here. Okay. So now we finish part B. Part C says prove that the magnitude of POQ is pi on 2. Find in terms theta the ratio. Okay, that's two parts of one question. I don't know why they did that. Okay, so angle POQ. Angle POQ. It's basically just when you find angles between complex numbers, that just means it's it's the angle of OP minus the angle of OQ. Yeah, and that just means that's a of OP over OQ, and that just means it's just I cot theta over 2, and that's the angle. Well, look at this imaginary number. It doesn't have a real part, so it's only imaginary. With no real part, we assume the real part is 0. So must lay like, oh god, okay, oh, okay. It must lie on the y-axis. So if we know lies on the if we know it lies on the y-axis, because because the angle comes from the positive x-axis, it must be positive 9 degrees or negative 9 degrees. Yeah. Yes. So, for example, if Q is here, the 1 plus this, yeah, if you do 1 plus this value, it should go right here. If you do 1 minus this value, do we do 1 minus? Yes, 1 minus. So if you do 1 minus this value, it should be over here. Should it? The G 1 minus. I think so. I think so. Yeah. Oh well. If it's only imaginary term, it should be only pi on 2 or negative pi on 2, and we said the magnitude, so it's magnitude of pi on 2, or magnitude of plus or minus pi on 2, and that's just equal to pi on 2. Yes, apparently that's what it is. Let me think about this again. Is this always the case? For example, if you find a point here, if you plus 1 to that value, it's just gonna be right here. If you minus 1 that value, so 1 minus that value, you do get a positive value. Alright. I think that's how it works, though. That is how it works. Because it must be how it works. But oh well, we're moving on. Okay. The next part of this question says find in terms of theta the ratio OP over OQ. The ratio of OP over OQ. Well, that's just OP over OQ. Yes, and now well, we're gonna make it into the actual things first. So it is just 1 plus z, 1 minus z, and we did this in part A. That just equals to I cot theta over 2. and because I is just 1 but in the up and down axis, so that just equals to cot theta over 2. And that's the answer, yes. Well, that how it works. If, for example, z is here, we do 1 plus z, which is I, well, 1 plus I, yeah, wait, yeah, 1 plus I must be 1 plus 1 plus I is right here. 1 minus I, 1 minus I is right here. They are, they should be, should they be 180? Because, oh, I'm assuming they both added a minus. That's why I was confused before. But yeah, oh well. Complex numbers are very weird. Oh, we move on to the next question. Question 2. Question 2 says let pz equals p z3 z to the power 3 plus 3pz plus q. It is known that pz equals z take k squared z take a. We have to show that, this is part A by the way, show that p equals negative k squared. We're not writing that first. Actually, we're gonna write prove p equals k negative k squared. Okay, so the use code question, you just expand this and then you get the variables. So we're gonna expand that first. So we're gonna write z take k squared z take a equals z squared take 2zk plus k squared z take a, and then we continue z3 minus az squared minus 2z squared k plus 2zak plus k squared z take ak squared, and that just equals to z3, oh my god, plus minus a minus 2k z squared plus 2a plus k squared 2ak plus a squared z plus ak squared. So we put them inside the format like this one. So, but we know that pz equals z3 plus 0z2 plus 3pz plus q. Then we know that minus a minus 2k equals 0, which means a equals negative 2k. And then we also know that 2ak plus k squared equals 3p. And we know that we can sub the a into this one, and that becomes, well, that becomes negative 4k squared plus k equals 3p. And then it becomes negative 3k squared equals 3p. And then it becomes p equals negative k squared. That's done for part A1. Now for A2, we have to find q in terms of k. Well, ak squared equals q. Equals, well, a we found here, that just negative 2k to the power 3 equals 9. Equals q, I mean. and then that just means q equals negative 2k to the power 3. And then for part 3 of this, let's see. For part 2, yep, should be, that's weird. Q. Oh, I think I did that wrong. Yep, that should be negative. I am very blind. And good thing I checked. I was like, where did the negative go? And that's that. Because negative 2 times negative a, negative k times negative 2k. Oh well. And part 3 of this says show that 4p 4p3 plus q2 equals 0. That just means 4. What's p? P is negative k to the power 3 plus q, which is just 2k3 to the power of 2, and that just equals to negative 4k to the power 6 plus 4k to the power of 6, and that just equals 0. And we're done. And then we have part B of this question. And then the part B is basically the same question but harder. So it's hz equals z3 minus 6iz plus 4 minus 4I. It is known that hz equals z minus b squared z minus c. Find the values of b and c. Let's expand it first. That just equals to z squared minus 2zb. I should start writing the thingies in the z's. You know what? My handwriting is fine. I don't need to do that. Plus b squared, and then that's z minus c, and then that becomes z3 minus cz2 minus 2z squared b plus 2czb plus b squared z minus b squared c. Okay, now we put them into little bunches. Okay, I don't know. Minus z minus 2b z squared plus 2cb plus b squared z minus b squared c. That looked like a power of 3. I don't know why I wrote it like that. Okay. And we can see from this, oh my god, it was a 6. We can see from this that there is actually there's actually 0z squared inside. So we know that minus c minus 2b equals 0. And then we can make it so that c equals negative 2b. Ooh, and then we do know that 2cb plus b squared equals to 6i. And we sub the c in, that becomes negative 4b squared plus b squared equals negative 3b squared equals 6i. And let b equal, yes, let, with 6i, we can rearrange it first, and that becomes b squared equal negative 2i. B squared, let's see that b squared equals, where, oh, it's a negative here. We missed a negative here. That's why I was like, does not look right. It's like that becomes another I, and then it's weird. Okay, well, that's that. That's positive. And now we do let b equals x plus yi, and that becomes x squared plus 2xyi minus y squared equals 2i. And the real part of this is obviously x, y. The imaginary part is that and that. So that means there's a plus 0 here. So that means x squared minus y squared equals 0 and 2xy equals 2. So that means that in this equation, we can look at it and we can see how, oh, these must be the same number. And they can be they can be both negative, positive, doesn't really matter. But here, we want that xy equals to 1. So that means xy can either be 1, 1 or negative 1, negative 1. And they both work for this. So that means b equals to 1 plus I or minus 1 minus I. Okay, so now we have to test these. Now to test these, we still have one more thing we haven't used. 4 minus 4i. Well then, where is that in the equation? That is right here, which is b squared c. So b squared c just equals, because c, where c equals minus 2b, that just becomes minus b3, and that equals to, well, that equals to 4 minus 4i. 4 minus 4i. Now, where did the 2 go? I was like, c equals minus 2b. Okay. And then that means b3 equals, let's get rid of the negative. So that's just, wait, where did we get, oh no, we missed another negative. Negative right here. Oh my god. It's negative here, so the negative 2 disappears. And then that just means 2 minus 2i. Okay. And now, we just have to test each of these to find if they equal that. And then now we do 1 plus I to the power 3. That means just, we use the 1, 3, 3, 1 from the Pascal's triangle. We can get 1, and then, because, okay, let's start with 1, yeah? 1, and then it'll be 1i, so it'll be 3i, and then it'll be 2i's. 2i's becomes negative, so minus 3, and then there'll be 1i, so then you plus I. Wait, is that right? No, that is indeed not quite right. So when it's here, I is 0, so nothing happens. When it's here, I is 3. I is 3, that's negative, and also I, so that should be negative. And then that is that right? No, this should be I, because there's one. Wait, that should be. This one should be I to the power of 3, which is. Wait, this one is just minus 1. This one have no more 1s, but all I, so I to the power of 3. This is I to the power of 1. I to the power of 1 is not negative, but the I to the power of 3 is negative. Okay, that's just negative 2 plus 2i, which is not that. That is wrong. Okay, oh my god, that is wrong. Okay, minus I 3 equals, okay, so negative 1 to the power of 3 is obvious. 1, 3, 3, 1. Obviously negative 1. Obviously negative 1. Now, negative 1 to the power of 2 is just nothing, but negative I to the power of 1 is negative I. Negative 3i, I. And then this 3 means there are only one negative one, so it is negative, but there's two negative i's. Two negative i's becomes a 1, and it should just be negative 3. And then when it's 1i, there's 3 negative i's. It should be negative I, but then the negative there, so it becomes plus I. Oh my god. And that will become negative 4. That is not right. We did something wrong. Okay. So the first one, do we know it's right? Yes, we do know it's right. But here, there should be one negative 1. That's correct. Should be two negative i's. Two negative i's. Two negative i's. I squared is... Okay, so let's see. Actually that's weird. That should be negative I squared times negative 1. So I'm gonna do that. I squared times negative 1. That is indeed, wait, that is just 1, because negative I squared is actually negative negative 1, so there should be a plus. And then now that becomes 2 minus 2, that means I minus 2i, and that's exactly what this is. That means this is correct. That means b equals negative 1 minus I. And now what's c? C is c equals negative 2b equals 1 2 plus 2i. Oh my god. And that's how you figure out all that. Oh well, that's a lot. It's a long video. Oh well, bye bye.